Okay, this is Vishnu Gautam. I'm going to present my research here. And the title of this research is SUESSA, Sustainable and Ultra-Elastic Stack Security Architecture for Securing IoT Networks of Future Smart Cities. And this research was carried out by Professor Norio Siraturi and myself. And today I'm going to present this presentation by representing this group. Here are the contents. I will start my talks from motivation, and then I will give some introduction about typical security architecture, and then threat resolving process. I'll give a little bit information regarding this SUESSA, the proposed security architecture, and its taxonomy, and few comparisons among the security architecture, and I'll make the conclusion. First of all, let me tell why we are continuing this research, or the motivation behind this research. Since a couple of years ago, I myself was involved in research of automation of traditional tools. These pictures in this left side show that it is a stone grinder which is used in Himalayan areas by the people of Himalayan areas in order to grind their daily consumption, daily foods. For example, this woman is grinding maize. They grind their maize or rice or other agricultural foods for their meals. They love it because they are using it from centuries ago. However, this is very heavy and it is used manually, and thus this is not user friendly for older women or older people and children. This is one of the reasons this tool is losing the popularity nowadays. And I have developed this tool in the right side. We are using the same stones here, and this has been automated by using DC motor, and which can be operated by using solar power and also remotely. So we would like to control this device remotely because the aging population is increased and it's very hard to operate, and we want to make it very sustainable and user friendly for all age of people. So in order to continue this kind of tools in this present era, the system should be very sustainable in different perspectives, and the feature of sustainability should be addressed while architecting the systems. Let me show you one video here so that you can see what kind of system it is. This is a very short video regarding this device, and here this device has been developed to make it fully automated. However, it has other problem. It has still lack of sustainability. The system, many systems have the sustainability issues, and we have addressed this issue because now this device can be used by children to senior people from anywhere at any time. However, there is still an issue that should be addressed, and this is a security issue, and which is a very challenging issue in security research also. The sustainability with security feature is a challenging issue, and that is why we are going to do research in these topics. And the other things that we should address are lack of cohesiveness, the issues of unnecessary overlaps or disjointed mess that makes difficult to prevent, detect, or remediate security threats effectively and efficiently. Similarly, most of the operational networks are still lacking comprehensive automation. Of course, many organizations have practiced automation, which are not fully automated, but because they are very hard to scale to meet today's risk management and emergency response requirement for network security. So we'd like to devise a kind of method that can address this kind of future issues which could emerge in future networks or future networks, smart cities or smart villages. Let me show you the typical architecture, which is based on bit architecture. For example, this is the example of bit architecture. They have a packet bit, top bit, file bit, and live bit. This bit collect the data and parse them and ship those data to log module or for the big data search engine. And after doing some kind of data classification or analyzing, and they explore it and visualize. And this visualization or classification technique could be useful to detect the threats and to address the security issues. And the typical threat incident resolving and reporting process practice in most of the organizations is displayed, is modeled here. For example, when the data center detect the threat either by manual process or in an automatic way, the incident notification goes to the respective team, security team, and they apply their security technique to address the threat. And if once this threat is resolved, the report will be generated, and this report will be sent to their upper level. And once the threat is resolved properly, then this will be validated as a resolved threat. And this is a generic threat resolving process for which the SUESSA architecture will support in our research. So this is the proposed architecture, which is composed with these 4 additional components. And so this research, this package does not replace the traditional architecture. However, it will supplement the conventional architecture with additional new features. These feature bit, sustainable bit, and sensor bit, these are the new components that we are going to develop, which are under construction, and also the machine learning. Though a lot of research are undergoing in these topics in order to classify or to predict the security threats or security vulnerabilities in the system, we are also conducting research and to address the security field holistic approach by adding the other novel algorithms and ideas, not only in the field of classification but also in the field of security prediction. Also, we'd like to contribute while collecting or parsing the data. So, though these features are under construction, the research is going on. Number one, in under 1, 2, and 3 or 4 categories. So let me show you the taxonomy of this SUESSA architecture. The number one is traffic or data pipelining and monitoring. In SUESSA, it acquires the data and streamline it to the specific tool or devices in order to pipeline the data. For example, it captures data from IoT sensor or servers or any other future network devices, security cameras, and cache those data at the edge, process and pipeline those data for further processing and classification. And during classification, this is the model that it will construct the topology, generate, capture the traffic, prepare training data, train the data, and use model, and finally it will classify the traffic. One of the most important component in SUESSA is sustainability, and we are going to address this component by applying these 3 important features. One of the feature is negotiable security components, which is capable of intercommunication between the security components. For example, while there is a new security threat, these components will communicate to each other and tackle the issue, and they will be able to run diagnostic component. The other one is auto scaling, because auto scaling is very important for sustainability in order to provide sustainability into the architecture. The auto scaling components which are capable of provision and deprovision automatically and in timely manner and without human intervention in response to dynamic change in the networks. Auto scheduling is done on the basis of auto scheduling algorithm. The details of auto scheduling is by using sophisticated machine learning methods and implementing auto scalar architecture. SUESSA will enhance the auto scheduling feature in security architecture. SUESSA is an auto security architecture based on prior set schedule. These schedules are set by using machine learning components for predictable load changes. Scale out and scale down activities of resource will be performed on the basis of predictive features. And this is the comparison table, architecture comparison between SUESSA and other available security architecture, which are given in this table. And the detail of this table is explained in our paper. The SUESSA, in our comparison, we found that we are trying to address the sustainability, elasticity, and machine learning. These 3 components will surpass the already available security feature of other security architecture, because we are not replacing those architectures totally. However, we are going to supplement this architecture with additional new features, so that we believe that SUESSA will surpass the security features of other architecture. And please reference our paper for further details. And at the conclusion, SUESSA aims to address the problem of security threats that may arise in future smart villages or smart cities. For example, our first example of stone grinder is believed to be used in future smart villages. And those tools, as far as they will be connected to internet, there will be security threats. Therefore, there will be new challenges in those kind of devices which are still not faced till date. However, in the future smart villages, those security challenges will be detected, and thus we are focusing our research to those kind of systems. Security architecture that address the issues of sustainability is a crucial issue for future networks. And there are a lot of machine learning approaches that can cope up with the constant change in the cyber attacks. However, because sustainability features are lacking in those security architecture, we are going to apply those components in SUESSA. Finally, sustainability with security is a very important issue to realize the super smart society or to realize future smart village. Thank you.